Finding zeros of polynomial functions and the intermediate value theorem. Find the zeros of the polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. To find the zeros of this function, we're going to set the function equal to 0 and solve for x. Here we have a function that has 4 terms. So in order to factor this, we're going to use the grouping method. To do that, group the first 2 terms and the last 2 terms. Now I'm going to put a plus sign between the 2 groups and take the sign with the second group. Now I'm going to look at each group and factor out a common factor. So I have an x squared that's in common between the x cubed and the 4x squared. When I factor out an x squared, I get x plus 4. Next, I'm going to look for a common factor between negative 9x and negative 36. We have a negative 9 in common, so I'll factor out a negative 9. And I'm left with an x plus 4. Lastly, we're going to list our factors, and in order to do that, I'll take the values in front of the parentheses. So we have an x squared minus 9, and that will be one factor. And then the second factor is going to be one of the repeating expressions in my parentheses. So that will be the x plus 4 factor. Then I'll set each factor equal to 0 and solve for x. So with x plus 4 equals 0, I'll subtract 4 on both sides, and I get x equals a negative 4. With the x squared minus 9 equals 0, I'll add 9 to both sides, and then take the square root of 9. And remember, when we take the square root, we'll put the plus minus next to the square root sign, so I get x equals plus or minus 3. And my zeros are then x equals negative 3, positive 3, and a negative 4. Now for this problem, I'm also asked to find the multiplicity for each zero. So each zero occurs once, so that means that the multiplicity of each zero is 1. I'm also asked to state whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. Now all of these zeros have a multiplicity of 1. Since the multiplicity is odd, that means that they're going to cross the x-axis at all zeros. So the graph will cross the x-axis. And these are my 3 answers to this problem. Use the intermediate value theorem to show that the polynomial f of x equals 2x to the 4th minus 4x squared plus 1 has a real zero between negative 1 and 0. In order to use this theorem, we're first going to find f of negative 1. Then we'll find f of 0. So f of negative 1 is 2 times negative 1 to the 4th power minus 4 times negative 1 squared plus 1. Negative 1 to the 4th power is a positive 1, so this becomes 2 times 1 minus negative 1 to the squared power is also a positive 1, so I have a 4 times 1 and then plus 1. And this becomes 2 minus 4 plus 1, which is negative 2 plus 1, which gives me a negative 1. So f of negative 1 is negative 1. Now I'm going to find f of 0. And I'll just substitute a 0 wherever I see an x in the original problem. And then we have 0 to the 4th power, which is 0, so that's 2 times 0, minus 4 times 0, plus 1. And this becomes 0 minus 0 plus 1. And f of 0 equals a positive 1. Now, the intermediate value theorem says that if we have opposite signs in our resulting formulas, then there is a real zero between -1 and 0. So we want to check to see if we have opposite signs. And we do. We have a -1 and then we have a +1. So since we have a negative number and then a positive number, we do have opposite signs, so that means that there is a real zero between -1 and 0.